My name is Giovanni Frisoni. I'm a clinical neurologist. I'm Deputy Scientific Director at the Italian Center for Alzheimer's Disease in Brescia, Italy. Outgrid came out as a cooperative effort among three consortia, one working in Europe called NewGrid, one in the US called LONI, and the third one in Canada called CBrain. These consortia are all providing services to neuroscientists in terms of providing access to large data sets, providing sophisticated algorithm pipelines to extract disease markers from scans, and provide computational resources. So it made a lot of sense, it makes a lot of sense to have them work together and be interoperable, such that a scientist might access the resources staying in one, the other, or the third one without knowing what he or she is accessing, which would greatly enhance the usefulness of these services to the community. This is the Outgrid vision. Outgrid is a small project in itself, is a so-called support action. So what Outgrid could do was to kickstart the interoperability effort. Making three complex systems, such as those that I've described, interoperable is a huge effort. It's like having BMW, Mercedes, and Fiat join to develop the same car, the same model. It's not an easy deal. But it's something that might prove extremely useful to the neuroscientific community. And Outgrid has barely kick-started this effort. It wants to be the sparkle that will start a big fire. The aim of the meeting today is to call all the major stakeholders, meaning neuroscientists, of course, but also who are the users, the final users, but also ICT scientists. If they're not engaged, nothing will happen at the infrastructural level. And also, last but not the very least, funding agencies. What we want to extract from this meeting is that funding agencies commit to fund their own infrastructures, but with a strong eye towards interoperability. What the European Commission should do, what the US government and Canadian government should do, and Indian government and other governments who want to join this idea, what they should do is to fund the development of their own local infrastructure, but not as a standalone entity. They should give ICT scientists the mission to develop it to be interoperable with everything else that's there in the world. If the funding agencies commit themselves in this way, ICT scientists and neuroscientists will follow. There's a number of both political and technical challenges. The technical challenges are huge, as I said. Research and development efforts to make these infrastructures interoperable are not trivial, but they can be overcome. It will take effort, it will take money, it will take time, but it can be done. The political hurdles, the political obstacles are less tangible, but maybe more tricky, because each funding agency has its own agenda, its own policy, its own strategy of funding programs. So it's much easier to have scientists agree than funding agencies agree. But this is a very good start. It's a very good, promising start. Neuroscience is changing. It has changed, but it will change even more in the coming years. The big change has been brought about by a large project funded by the US government called Alzheimer's Disease Neuroimaging Initiative. What they have done This is a $100 million project lasting for 5 years now and renewed for 5 more years. What they have done is to scan a number of persons with variable degrees of cognitive impairment and to study them very accurately every 6 months. And the resulting data, both in terms of clinical data, neuropsychological tests, and the imaging data, have been made public. You can download all the ADNI data set if you wish. You're being given access if you simply ask, if you fill a form and ask access and explain why you need it. So this has changed dramatically the way that we study the brain. Because in the past, there were a number of imaging laboratories in the world with their own small data sets. Each had a small data set of 100 patients, 200, 300. But the data that we're talking about now is made of thousands of scans. Now there's about 8,000 scans that will be 15,000 in a few years, and more similar initiatives are joining. So there might be more, not only the US data public, which is what we have now, but in the future we might have a European data set, a Japanese data set, an Australian data set, Chinese data set, an Indian data set. And you can imagine the size of these data. And the reason why we need these large data sets is that we must extract disease markers, signatures based on imaging, signatures of the disease in the brain, signs that the disease is there and it's progressing. This is what we use to develop drugs. Disease markers is what we use to develop drugs. If we don't have disease markers, no drug.